we have heat loss from a hot water pipe example from chapter 9 on natural convection. So we have the surrounding temperature, T infinity, and we have the temperature of the pipe, 70 C. We have the length, 6 meters, diameter, 8 centimeters. Given all of these properties, and we need to determine the rate of heat loss by natural convection. Okay, so in previous chapters, we really cared about the Reynolds number. We really care about the Newton number. We still care about the Newton number because, again, the Newton number is related to H, if you don't remember from chapters 7 and 8. But we're going to learn another dimensionless quantity that we really care about. That is the Rayleigh number. So the Rayleigh number is just another number that we care about. It talks about natural convection, and that's why we care about it in natural convection context. So the formula for this is G times beta Ts minus T infinity times the diameter cubed times V squared times the Prandtl number. So we have G, that's 9.81, because we are in meters and kilograms and all the things. Then we're given beta is 1 over 318. So I'm just going to leave it as 1 over 318. This does have to be in Kelvin, so make sure you're paying attention to that. And then we have Ts minus T infinity. Now you might think, oh, we have Kelvin over here. This needs to be in Kelvin. It could be in Celsius or Kelvin because we care about the different temperature difference. If we added 270 to 3 to both Ts and T infinity, then subtracting them would just get rid of the 273. Now we have D cubed, that's 8 centimeters, so 0.08 meters cubed, divide by viscosity, that's this right here, 1.75 times 10 to the negative fifth, and this whole thing squared. And then we multiply by the Prandtl number, which we're given 0.72. Alright, so let's type all of this into our calculator. We get 1.86767 times 10 to the 6th.
Not really.
Okay, so I grabbed this table real quick because we want to figure out the Newton number, because again we want the rate, so we need H to get Q, and the Newton number is a great way to get H. So we are looking at this equation. This relates the Newton number experimentally to the Rayleigh number, which we just calculated, and the Prandtl number. And we are looking at a horizontal cylinder. So we're going to use this equation here. So let's write out the equation. We have the Newton number is equal to 0.6 plus 0.387 times the Rayleigh number to the 1/6 divide by 1 plus 0.59559 Then you divide that by the Prandtl number. This is to the 9/16. And this entire bottom is to the 8/27. It looks so weird and so confusing, and that's just because they determined this experimentally. So we substitute this Rayleigh number that we just calculated and the Prandtl number that we were given into this equation. So the Prandtl number of 0.7241 and 1.867 times 10 to the 6th. We substitute those in, and then we get a Nusselt number of 17.39. And then, just like in chapter 7, we know the Nusselt number is h d over k, which means we can solve for h, and we can get q from there. So I will go ahead and do this, because I might as well show you again. Move the k over, divide by d, that equals h. So we have the Nusselt number. We have k, that should be given, 0.02699 times the Nusselt number, which was 17.39. We calculated that one. Divide that by k. I'm sorry, divide that by d. D was 8 centimeters, so 0.02, or 0.08. We get h from that. That, type it into our calculator, 5.867 watts per meter Kelvin. Perfect. Now we just get Q. The formula for Q dot, the exact same as been since the start of heat transfer, H times the surface area times the surface temperature minus T infinity. So this is a cylinder, so the surface area is pi d times L. Then times Ts minus T infinity. Well, H 5.867 times pi times D 0.08. L, what was L? 6 meters. And then 70 minus 20. Then we get Q is 442 watts from natural convection. So, boom. That's exactly what we were looking for. So that is the beginning of natural convection. So we introduce a new number, the Rayleigh number, and use that to get the Nusselt number, to get H, to get Q.